Question 3. Air is being pumped into a balloon in the shape of a sphere so that its volume is increasing at a constant rate of 50 cubic centimeters per second. We deduce that the rate of change of the volume, since it is increasing, we have positive 50. Find the rate at which the radius of the balloon is increasing when the radius is 10. When the radius is 10, we need to find the rate of change of the radius. So we need to find the RDT. We are given that dV/dt is 50, and we know that the volume of a sphere is given by 4/3 pi r cubed. So we differentiate this with respect to t. We have dV/dt on the left side. 4/3 pi is just a constant. When we differentiate r cubed with respect to t, we apply the chain rule to obtain 3r squared dr dt. dr dt is what we need to find. We are given that dV/dt is 50, so the 3 and the 3 we can cancel off. Then we have 4 pi r squared. R is 10, we have 10 squared dr dt. 50 is 4 pi, r squared is 100 dr dt. We can divide throughout by 50, then this 50 becomes a 1, the 100 becomes a 2. So 1 is 8 pi dr dt. To isolate dr dt, we divide by 8 pi throughout, so that dr dt is 1/8 pi. Then the radius is increasing at a rate of 1/8 pi centimeters per second. Question 4. We are given a diagram where the graph of cosine theta is given, and we are also given a transform function. So this blue graph here is transformed from y equals cosine theta, and we need to find the equation of this upper curve. We can see that for the equation of the upper curve, this is the transform cosine function. The maximum is at theta equals 0. So this graph do not have a phase shift or a horizontal translation. The graph that we want is in the form of A cosine k theta plus c. That is the equation that we need to determine. We need to find the value of A, K, and C. The maximum is 5, the minimum is 1. So right in the middle, we have y equals 3. That is the equilibrium line, the sinusoidal axis. So we see that C has a value of 3. And to find the amplitude is the distance from the sinusoidal axis to the maximum. That is 2 units, so we know that A is 2. To find the value of K is always given by 2 pi over the period of the function. This cosine function has 4 pi as its period. It completes one cycle in 4 pi. We know that the period is 4 pi. Then K is 2 pi over the period, so it's 2 pi over 4 pi, which is 1/2. The equation that we need to find is 2 cos 1/2 theta plus 3.